Maintaining a synchronized state across an enterprise Active Directory topology requires a massive, continuous exchange of data. Thousands of nodes must constantly reconcile user credentials, access rights, and structural configurations. To manage this constant flow, Active Directory relies on an interval-based change notification system. Rather than broadcasting every minor edit the millisecond it occurs, the system is programmed to queue updates and wait. This diagram illustrates those baseline latency parameters. A domain controller, the central server that authenticates users and enforces security policy, will hold outbound changes in a queue. On modern systems, it waits exactly 15 seconds. On legacy Windows 2000 servers, that delay extends to 300 seconds. This program delay is highly intentional. It optimizes network bandwidth by batching routine administrative updates together. Instead of sending 50 separate network broadcasts for 50 minor changes, the domain controller waits for the clock to run out and sends one compiled payload. Batching preserves bandwidth and ensures stable network performance during routine operations. But during a time-sensitive security event, that 15-second delay creates a dangerous window of vulnerability. If a network is under active attack, waiting 15 seconds to lock an intruder out of the system gives them an eternity to exploit other nodes that haven't received the update yet. To solve this, the architecture includes a hard-coded override mechanism known as urgent Active Directory replication. As this diagram shows, urgent replication bypasses the queue entirely. It uses RPC over IP, Remote Procedure Call over Internet Protocol, which is a method for one program to request a service from another computer, to instantly notify partner domain controllers of a critical change, reducing the wait period to 0. This override is universally enforced. It applies automatically to all domain controllers operating within the same physical site, regardless of the underlying Windows Server operating system they are running. Across geographic boundaries, the rule requires manual configuration. Urgent triggers will replicate instantly between different sites only if administrators have explicitly enabled inter-site change notification. Urgent replication operates as an emergency reflex. It deliberately sacrifices the bandwidth efficiency of batching to enforce immediate, network-wide consistency when it matters most. The RPC IP bypass is highly exclusive. Out of the millions of variables Active Directory tracks, it reserves urgent replication for exactly 6 specific events. This shows the first trigger, assigning an account lockout. When an attacker hits the failed login limit, the domain controller instantly locks the account and broadcasts its status. This zero-latency broadcast stops lateral movement, preventing the attacker from authenticating elsewhere before the 15-second timer expires. We can see the system's priorities clearly by looking at the exact opposite action, an administrative account unlock. An account unlock is completely excluded from urgent replication. When an administrator manually restores access for a user, that update drops straight into the standard queue and waits for the 15-second clock to run out. The system instantly broadcasts a lockout, but forces an unlock to wait in line. Urgency in Active Directory is strictly asymmetrical. The architecture ruthlessly prioritizes defensive lockdown over restoring user access. Beyond individual user credentials, the RPC/IP bypass protects overarching domain-wide security rules. Here is the second trigger, modifying the account lockout policy. Altering how accounts freeze forces an immediate update. The third trigger is changing the domain password policy. Both updates speed through the bypass lane, while routine account unlocks wait in the 15-second holding queue. Zero latency is required here to prevent enforcement disparities. Without an instant sync, an enterprise could have a fragmented environment where different domain controllers enforce conflicting password rules. The bypass mechanism also extends deep into the backend architecture to protect the local security authority. In this conceptual diagram, we see the fourth trigger, changing an LSA secret. The local security authority is a protected subsystem that authenticates users. An LSA secret is highly secure private data stored by this subsystem, like a password establishing a trust relationship between domains. Modifying this secret demands an immediate sync to ensure inter-domain trust remains intact. Any configuration change that rewrites the core rules of domain access is treated by the network with the exact same urgency as an active brute force attack. The final 2 triggers protect the absolute highest tier of the Active Directory architecture, the domain controllers themselves. This hierarchical map illustrates the 5th trigger. If a domain controller changes the password on its own computer account, that credential update flashes across the network immediately. Because domain controllers represent the ultimate operational authority, any desynchronization of their own credentials would cause immediate structural fragmentation, blocking them from replicating data entirely. This need for structural integrity also applies to specialized single master operations roles, specifically the RID master. This highlights the sixth trigger, changing the RID master role owner. A relative identifier uniquely identifies every domain object. The RID master is the sole server dispensing blocks of these identifiers to other domain controllers, enabling them to create new accounts and security groups. Transferring the RID master role is a complete shift in structural power. It requires zero latency notification across the network to prevent two servers from acting as the master and creating catastrophic identifier collisions. 6 specific events: account lockouts, lockout policies, password policies, LSA secrets, domain controller passwords, and the RID master role. This schematic illustrates the entire overwrite index. But the critical question is what characteristic unites these 6 precise events, elevating them above all other administrative actions. None of these triggers correlate with routine operations. High-volume data entry, creating new users, and standard resource provisioning are all left in the standard queue. The defining threshold of Active Directory urgency is strict. An event only bypasses the queue if a delay compromises immediate network defense or core structural authority. Active Directory's dual-tier replication design is an exercise in strict prioritization. It perfectly isolates routine state changes from critical security enforcement. Urgent replication ensures that the most critical system updates bypass the standard 15-second or 300-second change notification queues by firing direct RPC/IP alerts. It guarantees this consistency across all operating systems natively within a site and bridges inter-site boundaries when explicitly configured. An enterprise network security posture is ultimately only as strong as its slowest update. Through these 6 triggers, Active Directory guarantees its critical defenses are deployed everywhere, all at once, before the standard clock begins to tick.